Okay, I think I will be slowly starting. So, привет. Hello, nice to see you here. Did you have a good day? Yeah, really, this is an amazing conference for me. I was once before only in Lviv, at JD Lviv. That was also a blast. Let's say I really liked the event. And I just regret I haven't been more often, but I'm sure next time there will be any call for papers, actually I know. So like conference at Ukraine, I will sure submit something. I really enjoy it, and it's for me like a lot of fun. So I'm not only the conference, the people, I'm from Poland. So I think we are culturally similar. Like I attend a lot of events in different countries. Well, actually, I like to be here between, us, let's say. Okay. This presentation, while at the first room, at the main stage, someone else is presenting how great some platforms are. I'll be in this room presenting how ungreat they are. What are the problems? Well, on the other sessions, they will be full of love and beauty. I will show you a dark side. This is a session of hate coming deep from my heart. Okay, so I'm Jarek. I'm a software developer, wizard, and an architect. That's how I call myself. Have you ever heard about ivory tower architects? So people that have so high vision of the stuff that they don't see anything anymore. So if you are ivory tower architect living in this tower, and one day you look too much, you can fall down. And that's how you become an architect. Okay. I work in Ingenious in GmbH. This is a company in Switzerland. And yes, we hire. By the way, we have some Ukrainian people on board. They are actually making that it's hard for us because they are too good. This is, let's say, what we see in Switzerland. Come on, when you are abroad, can you code a little bit worse for a moment so that, it's like my life as a developer is easier? I don't want you set standards too high. Okay, so we hire. We don't have table football. This is actually pros. We just pay with money. And when it counts, it's like you have to talk to people. I hate that, but Okay. I work with Java EE since about 2001. Actually, I read before I was playing, but let's say professionally since 2001. With Spring from 2006, I started with version 2. I haven't really used version 1. But I remember things like, you know what is EJB OSS? It's actually the first name of the thing that you might know as JBoss. But because it was using EJB, it was EJBoss. It was forbidden by some lawyers to use, and Mark Fleury had to change the name. I am that old. And I remember the times when I was reading about Spring in Action, I think that was the book. Probably I still have it in my library, about version 2 or so. I'm not sure. But I remember that half of the book was telling me how great is to keep configuration and stuff and everything, how I connect my beans in XMLs. Really, world is changing. So at the moment, I'm still using Spring and Java EE. I have one big project where it actually doesn't use that stuff, but I'm doing, let's say, small maintenance to about 15, I think about 15 projects. Let's say, sometimes in Spring, sometimes in Java EE, like plain Java EE in JBoss right now, mostly. And actually, I only have one main project, which is basically not Springly done, and or not Java EE. And one very critical, but I also do not commit much there. I just this is like the critical application of a company, and it's netty-based. But this is, let's say, stable. I don't code there that much. Okay, this means that I'm still mostly involved in Java EE and Spring. Of course, recently more in Spring. That's all the time. My perception of the stuff might be not the same as yours, as a typical developer, because I just like fixing stuff. I'm engineer, so I actually don't like that much greenfield projects. I do greenfield projects for sanity, but I actually have full joy when I see real production bug. Like production is almost dying. Give me that, give me that. I like it. So I'm fixing stuff. Why? Because I think the bugs is how I learn the most. This is the real. I love production. And I love when I can make it better. You know, concurrency, security, performance bug, Heisenberg bugs. This is what I jump. It doesn't mean I do a lot of those bugs, hopefully. I try to fix others' bugs. But I do it with pleasure. You know what the Heisenberg is? Yeah, so it's a very nasty bug. If you add debug line, the bug disappears. You remove debug line on production, and it manifests again. This is really funny. But typically, it means something is broken with concurrency. The thing is, my perception is I like to fix a bug. I like to understand what has happened. Is my fix valid? Does it really fix the bug? Or just I have hope it fixes? And then is very important point I do. I think, what can I do to not have this kind of bug in the future? How can we prevent during the review maybe some more unit tests, but what kind of unit tests? Everything was 100% covered, still a bug. Okay, what can I do? That is very important. So, and now, the most important sentence of this presentation. I do have some Java EE and Spring experience, really. A lot of years. Even now, I still learn it. You cannot learn, but you cannot learn everything. And I think they are doing too much harm at the moment to our code. Actually, the cost is really huge. We don't see that, but I will show you. And we have to think about doing better, because I see new and new bugs coming to production that actually only happen because we are using this stuff. OK. My story of something completely else. Let's just jump to something completely else, to the go-to. Who knows of an infamous go-to statement? Yeah. My first programming language was a BASIC. And in BASIC, on Commodore 64, who had Commodore 64? Whoa, come on, you are too young. OK. But there was a BASIC, my first programming language. I loved it. And there was this go-to, and you would do everything with go-to. But there was a guy, actually I wasn't born at that year, Dijkstra, that said that go-to statement is harmful. It does more harm than help. We should avoid that. I've heard about it somewhere beginning of 90s, when I was already coding BASIC. So I read it in a magazine, and I think, oh, this is kind of, this is obviously bullshit. Sorry for this word, but that go-to is the basic concept in programming. That was my perception. I cannot do anything else. Like, what can I do without go-to? Yeah? OK, but the guy was saying, like, the more go-to you use, the worse actually your code is. Yeah. The point is, this was not widely accepted in the business. Even many years ago, Frank Rubin gave a paper that actually this go-to considered harmful, this sentence was harmful because there are cases where go-to actually makes code simpler, easier to reason. And he was presenting those cases. OK? So he said that if we just follow this, don't do go-to at any cost, we actually introduce more costs and more problems. That was the Frank Rubin answer. OK, it went, I don't cite it. It actually still are those people. It's not that it disappeared. It happened like, I don't know, I think 5 months ago, someone was exactly arguing about this on a Polish message board for programmers. It's actually called for programmers, and was showing the code in C#, actually written by someone from, let's say, Microsoft, that was presenting how beautiful the go-to is and saying, now try that without go-to. OK? By the way, code doesn't really look beautiful. So Dijkstra reacted to the paper and said, actually, your code you present me shows you that you don't understand many things. You can do way, way better without go-to if you learned other concepts. And he presented that. It was like massacrating, answer no one wants to see publicly. But basically, yeah, it was the Dijkstra answered. It was really, let's say, partially root answer, but yeah. The point is this, however. From time to time, someone will present you, and it happens even now, a piece of code, isolated piece of code, with goto, and will say, in this piece of code, look, goto is actually helping. And maybe you are very smart, like Dijkstra, and say, oh, no, I can rewrite it totally and see it's even more beautiful without. Or you say, actually, yeah, on this isolated piece of code is actually, yeah, makes sense, but you know, there is something else. Because goto is actually has some things. It's performance. It's right now, jump anywhere. This is like what goto provides. Nevertheless, this is something you Java developers are not exposed to that, because even in 90s, when I actually stopped learning BASIC, it was already widely known that goto does more harm than help. Even if it helps in some very rare cases, it's actually so dangerous that basically it was forbidden concept. In Java, the goto is reserved keyword for the reason that no one should ever use it for anything. Like, just reserved so that you cannot use it in any framework or whatever. Because at the end of the day, if you use goto, it gets out of control. And you end with spaghetti. Actually, spaghetti code is exactly coined because of using goto. That you go to somewhere. What's the problem? Because with goto, if you can jump anywhere from any place, the thing is broken. Local reasoning. If you have a method in Java, let's say a well-written method, you will see the arguments and you see the result. And for given arguments, the result is wrong. You might see that probably the error is inside this method. If we have goto, it means someone might have jumped inside. You don't know what's happening. If everything's go okay, then it's okay. But if there is an error with goto, you have to analyze basically whole the code. The bigger the code is, the more frustrating this is. So it's like the problem of goto is if something doesn't work, you have to look at tons of places. Who could potentially jump here? It's the same, by the way, with global variables and stuff like that. OK, broken local reasoning. How much you have to read when something doesn't work? We love local reasoning, by the way. The best form of local reasoning is functional programming. But OK. Mainstream industry stopped using goto because it's actually, let's pay maybe this, that sometimes we cannot do something smart on a small scale, but we won't fail on a bigger scale. OK, that's the end of story of the goto. And goto of our times. Beans. This is exactly who is using beans technology. Raise your hands. Like, by the way, the thing is, what is a bean? I'm not talking about Java beans. Who is using Java beans? Getters, setters. Ooh. This story we don't do that. This smells, really. If you are forced because of the framework, then change the framework. Basically, no. This is not this kind of beans. By beans, I mean Spring beans, Java EE beans, CDI beans, JSF beans. They are all very similar. So who is using Spring beans somehow? Who is using Java EE, EJB beans? Who is using CDI beans? All less people. OK, who is using JSF? Whoa, great, because this is really the word. Oh. Guys, after this talk, hug this man. Let's say, he's constantly in depression. I tell you, I guarantee you that. I was doing JSF in the past. Then, OK, you need a lot of vodka. OK, JPA. JPA is widely accepted, but it also uses some kind of bean. What is the bean? The bean is the thing that looks like a class, like an object in Java, but actually doesn't behave like one exactly. Because, for instance, one very important thing about beans, you don't instantiate it by new. If you use new keyword to instantiate the bean, it behaves completely differently than what's expected. You know that? Who knows that? Who knew that before this talk? The rest of you are forbidden by law to use Spring or whatever. OK? It's forbidden by law. OK. So beans, the thing is, why do we have those beans? Who needs beans? For what do you need beans? Tell me. Any reason? Why do you use Spring at all? Did I hear dependency injection? Yeah. You need dependency injection container. This is what I call disaster number 1. Injections. Like, of course. What is the DI? Let's go to the Wikipedia. Okay? There's a blah, 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 blah. Okay, we don't read that text anymore. Like, you know, it is 21st century. No one reads such a long text. Too long didn't read. Passing the service to the client rather than allowing a client to build or find the service is the fundamental requirement of the pattern. Like, you pass the dependency, not that the guy there has to find it out on his own. You just give it to him. This is the thing of dependency injection, okay? You don't understand? Let's show that in code. This is a class myService, and as field db repo db. How creative. And then in constructor, I say this db is new db repo, and some kind of URL. Do we see dependency injection here? Yes, you're right. There is absolutely no dependency injection here. Haven't seen that. But here, we have the same service, but in constructor, we take db, and then we pass this db repo to the service. Do you see dependency injection here? This is exactly the canonical form of dependency injection. And Java as a language supports dependency injection natively from version 1 because it has constructors. And in many languages, object-oriented programming languages, and not even in those, you have built-in dependency injection because most of those languages have something like a constructor. That's everything you need. Who knows Uncle Bob? Raise your hands. He is famous for some cleaning. I forget. He was cleaning something. Something big, probably. And he has a blog post. Dependency, and there he presents the whole story, exactly arguing that someone says to him, you need some container like Jews to provide you dependency. No. And let me show you what the dependency injection is. And finally, his statement. Dependency injection doesn't require a framework. It just requires that you invert dependencies and then construct and pass your arguments to deeper layers. That's what we've just seen. You don't need any framework. But OK, but why do we use these frameworks? Because if you pass over several layers, it might be a little tricky, a little bit of code to write. Who would look like to do that? So we have frameworks that make that easy for us. So we inject with almost no cost. Yeah, problem solved. You inject whatever you want, wherever. That is exactly what I call technical debt. Because you do something now fast, and you pay the price later. I will show you the price. Because this is the price. If you can inject easily, everywhere, anything, you create spaghetti on an injection level. It's not the go-to, it's injection spaghetti. It tastes a little bit different, but it's the same story. Try to untie it. Try to follow. And this is the point. Injecting repository in controller with a smart framework, we do that. People do that. Injecting HTTP request deep into persistent layer, seen that, no problem. Framework will do that for you. Injecting just anything, anywhere, that's not problem, and then you have bin transfer diseases for gratis, because this is how everything is then a bin in your application, and you just don't know where actually layers are starting or ending. This is what I see in code. By the way, did you notice? Who knows that a singleton is actually, somehow smelly pattern? Who knows? Like, we don't do singletons anymore. Oh, you do. They just changed the name. They are now Spring Beans. By default, they are singletons. But, some people say, oh, come on, only bad developers do that. Reasonable developers don't do that. Yeah? Of course. Because that's exactly the reason why people were saying GoTo is OK. Like, reasonable developers use GoTo wisely. OK? Because I know who has a Scrum in his team. or who has any kind of agile? You know what this is? This move, it's just an hour before demo, and you have to present something, and you push it. You push the functionality without review, without anything, because you have to present it. And everything goes then. Because what is the most important thing in Agile, in Scrum especially? What is the biggest value of Scrum? Well, what do you want to deliver? You want to deliver beautiful velocity, always increasing, and nice bear-down chart. That's the thing I learned. And anything goes an hour before demo. And then any injection goes. And it stays there forever. I am even using this kind of thing. Take all the classes in your code, count how many inject or auto-wire or whatever injections they have. Doesn't matter if it's really formally with annotation or not. Just count it, how many per class, and find the best class. Which numbers do you get? Tell me, what numbers you expect in your code? How much? 12. Cool. Who gives more? How much? 18. Oh, that's mature already. Who gives more? Yeah? 30, yeah. By the way, so typically in a business code, I see something below 20, like 18 I see normally. And this is even the code that I actually consider, okay, this looks like not the better than average. And the people on that presentation were telling me, I cannot tell you this is true, but they were telling me that they have actually counted and they had 100. Can you believe a class has 100 injections? But I can tell you, even 10 or 12, if you have a class with 12 dependencies, can it actually be, let's say, behaving like a conformant to the single responsibility principle? It's 12 responsibilities probably principle or something around. It's surely not okay. Very far away. And if it's 18, it's even worse. And if it's 100, it's like, you have to drink a lot. This metric, by the way, I call level of beans obscurity. And you do it for whatever, like for EJB, for CDI, it's the same story. Like how many things you depend on. By the way, some people even say, that's exactly why we need containers, because if I have 20 dependencies, how would you do construct it manually? You would get tired. Yes, of course, you're right. Is it really the solution? Okay. So the solution. In few steps. I will not only be giving you hate from my heart, sometimes giving you some solutions that I use. If you have this class with 3 auto-wired annotations, it's not that bad. But it can be better. Of course, it's simplified. I don't put everything. This is simplified. You understand that it has getters, setters, and everything, of course. Yeah. You can do one step better. And by the way, who knows this blog post? Oliver Gierke. This is a guy from Spring, actually, contributor. You should never, ever do the field injections. Okay? Even if you are a fan of Spring, if you think that Spring is beautiful, you make it better if you don't use field injections. Do constructor injections. I do confirm that. This is where the guys from Spring and I totally agree. Move your dependencies from fields to be injected at constructor. Because otherwise, actually, this is a really nice blog post. I recommend you to read it from Oliver Gierke. Otherwise, you are just begging, I want to have a null pointer exception on production, please. OK. But typically, you don't want to see that. OK. But then there is a step 2. You can delete this auto-wire. This is very simple. This was already better. Now it's perfect. But OK, I will explain you later. Because some people say, if you have to do this manually, you will repeat a lot of new statements. The thing is, yeah, you might be right. But when I was learning coding, I learned how to deal with repeating. I can extract the repeating stuff to the functions. If something repeats, I can extract this code to function. I don't have really to repeat all the time, even if it is new. I can use factories, providers, and actually plenty of design patterns help me to deal with repeating code in dependency injection done manually with constructor. OK. By the way, it is actually really better because I already did this step with some applications that they were despringified. Because normally, if you have this container, you make almost everything bin. Even if something has only one instance and actually doesn't use any dependency injection, because it has no cost. So if you think, after all, you might realize that instead of hundreds of bins, that you have only 3 things that actually need some kind of help from dependency injection, and the rest are normal classes that you can basically easily construct. Like, for instance, services typically don't need that. You have typically one instance of service. Maybe in test you have some mock service, but that's all. One example from Kotlin. By the way, I didn't use specific Kotlin stuff because there is something called lazy. This comes from package waiver, which is basically the new better Guava. It has something like lazy off. And with that, and it's still to some extent possible in Java, I can easily say, this is basically the place. Each of these lines represent annotation like a service or component, whatever. This is how I defined LV component with these dependencies. And then you can say, create me module, stones module, whatever it was for something like a stones shop. But module, but with a little bit different repo, but with a little bit different DB sequence. You can do that easily with Kotlin. A little bit less nice with Java. OK, I forgot to put a link to my GitHub. I have something like that under Ratpong when I present dependency injection with Java without any problem. I present how it's on a bigger scale done without any help of framework. And how does it look at the end? We have on the right container, inversion of control container that creates all those bins for us and injects everything anywhere we want. On the left, it's manual DI that a lot of people are using. By the way, in Scala world, in Kotlin world, everywhere, it's just not very popular in Java for I don't know which reason, but it is. It's not that manual DI is that just beautiful. It is a small pain. When you have class with 3 dependencies, when you enter the 4th one, you see, oh, that's a little bit too much in my constructor. Maybe I split this. Now, it's easier to split class, which has 3 dependencies, than it is to split when you see, oh, it's too much, but it's already 24th dependency. So you see the problem sooner, and you have small pain every day. After some time, you will see that it's much better to see a disaster after months, when it becomes too big to handle. Basically, if I have 18 dependencies class, I know I cannot untie it. It's already such a spaghetti you cannot, because you take one part and it all falls apart. OK. You end with something like a tree structure. Class depends of two things, depends of 3 other things, blah, blah, blah. It ends up like that. On this, my project, Ratpong, it exactly looks like this. And on my projects, I do looks like this. But no, unfortunately, not everything I can have on a GitHub. On the other hand, you have something like a ball of mud. Actually not. It looks like, for me like a messy cake. There are layers, but they are sometimes a little bit mixed. Yeah. And then you end 3, 6 classes. Really, if someone has 6 dependencies in constructor and has to create that, he feels the pain. He simplifies it. Before it's too late. On the other hand, it's like 5 18s are a good one. Good numbers, actually. Better than average. OK. This is how manual dependency injection ends. This is still a spaghetti, but it's not that bad. You can easier find pieces, and you can take them, like the whole parts of them. OK. By the way, there are worse things than singletons. Who knew there are other kinds of bin in Spring than singletons? Which are the worst? OK, the worst are request scoped, or session scoped, or basically anything thread local. What is thread local? Who knows? OK, cool. All the people that knew how thread local works, you can work with Spring because you know how it works. But other people shouldn't touch it. OK. So thread local is a thing that we can locally store something. It is like a global variable, but it's not fully global. It's global for a thread. It looks nice, but it's horrible in practice. Why? Because For instance, this piece of code, and it happened to me many times. We have a method C, which takes two arguments, A and B. And inside, I make a call to one other method, giving argument, passing argument A. OK. Then I call method 3, passing argument B. This is easy. And one day comes someone for a business and says, oh, we don't need to call this method 2 anymore. We don't send some email. OK, you can uncomment this piece of code. So I uncomment this piece of code, and I see no one needs argument A. I even removed an argument A. And then I refactor the code, run the test. They are all green. Go to production and get the null pointer exception. And then I realize we will not analyze this code, but with requests code bin on anything that is thread local, it's easy in the method 2 to store A and then take this A argument in the method 3, which was officially not depending on A. And by the way, this is not something like an edge case, stupid people. This is what's happening on production. I have that in a system that were written by the normal people. Really. And by the way, if you use something which is using Spring Batch, this is, let's say, informally standard way of passing things in Spring Batch. I was surprised. Just behind the scene, you pass something, so that no one sees that it's actually used. How cool. This is the best trolling, yeah? And at the end of the day, it breaks local reasoning. Because you see, this method depends on those two arguments, giving me strange result. The error must be here. No. It's somewhere else because someone somewhere is not injecting something correctly. How cool. So the problem at the end of the day is, I have these production bugs. And I don't know. I know how to fix them. I find those problems. The problem is I don't know how to defend against them. Because any small change in a system, I remove argument that it's potentially not used and everything falls apart. And tests are green because what are tests testing? They are testing mocks. Who is using Mockito? OK, thank you. I give, let's say, greeting from Stepan Faber. He's author of Mockito. I bet, because I've seen that, most of you are testing if Mockito still works correctly. Mockito is the best tested framework in the world. I see every day thousands of people in corporations are testing if Mockito still is correct. Really. Like, you cannot break it anyhow. It's solid as hell. OK. So what I say to containers injections, no. No. OK. By the way, it's not only me. Tamer Gabel, and by the way, a lot of people. He said, this is a nice presentation, slaying sacred cows. If you see benefits of IOC containers for this dependency injection, it only means that you already lost a control of your code base. Really. And his presentation is more detailed how other harm it makes on tests and stuff like that. I have to share time for some other stuff, so now I'll go to other topics. Because this is not only this. We use beans for some other thing, even worse. Who knows? OK. Aspects. Transactional. Who knows a transactional? That's my favorite one. What do you do when transactional doesn't work? Did it happen to you that transactional didn't actually work? Yeah, it happens. Yeah, this is cool. So once I was analyzing the bank application, and I found out that this application was 18 months on production without transactions, on auto-commit, because transactional wasn't working. There was a reason for that, very crazy one. But it was really hard to find it. By the way, tests were green. In tests, transactions were working properly. OK, why transactional cannot work? So how can it happen that you have a transactional annotation in front of a method and is actually not starting transaction? What could happen? OK, no public, like a private method. Local call. Who knows this? That if you call this from another public method in your bin, the transactional won't work. Who knows this? OK? You can use still Spring. Other people are forbidden by law. Because you don't know how dangerous it is. You may end with no transaction on production. This is something no one wants. OK. Or someone instantiated. Nowadays, we have so many things with convention that you don't even have to put those annotations. And people see, oh, that looks like a normal class. I instantiate by new. And then, whoa, how cool. Or it's Kotlin final class. By the way, this is mostly not true because in reality you would get error by starting the application. But this, you know, if you use this thing inside parallel stream, in other thread than originally started, but you know, we have right now 16 cores or more cores processors, but who would use threads? We don't touch threads, of course, yeah? Only accidentally, sometimes. Sometimes you don't even know that you are using threading nowadays. And if you mix threads with these annotations, this all falls apart. Or troll aspect. I always thought this is very, like, no one does it. But actually, in June this year, it happened to me. I was given an application where something didn't work, actually transactional, and no one knew why. I analyzed it. Oh, this is on public method. There's no threading, anything. But it's obviously, I found it even in a debug, doesn't work. And you know what happened? This wasn't the normal transactional. That was transactional from some company package. Someone written own transactional annotation. But you know, typically when you look at the code, you don't see imports. They are folded by IntelliJ, very smart. And this is transactional, which is not really transactional. It's untransactional transactional. But by the way, they were not smart because they could write some aspect that would work without actually being annotated. So actually, someone might have used normal transactional and it still would be invalidated by some other aspect. You could do that with magic of Spring, of course. And this is actually what happened to my production once. There was missing one jar, really, one jar. And everything was working just without transaction. This is really a cool story. And on top of that, you actually deal with JPA. Who knows that managed detached problem with JPA? It really breaks the local reasoning. Well, who knows what dirty checking is? Yeah, there is such thing. And at the end of the day, if you put it all together, magic of Spring with transactional, magic of JPA, you don't know what's going on. And by the way, that's not all because databases bring this. Who has ever had transaction isolation level problem? Who even knows what this transaction isolation is? Like, combine that together. This is a mess. This is so many potential problems. It's so hard to analyze. You have to basically go through whole your code sometimes to find out where is the problem. This is just a madness. Yeah. This is how I feel confronted with that. I can find a bug for you. But if someone asks me, is it now correct? No, while analyzing these bugs, I found so many places that smell that I cannot say anything. Let's have a hope. By the way, this is typical, of course, stack trace. You know, here is your business logic. If transactional doesn't work, where do you put breakpoint to find it out? Because actually, this is started before the problem happens while your application is starting. You don't even have a place to put a breakpoint. You actually need sources of Spring. I really know sources of Spring because I know where to put breakpoints there to find out where something wasn't started, really. It's even worse with WebSphere or some stuff like that. And by the way, all aspects have the same problems. Like secured, roles allowed, cacheable. Like, can your company actually afford this, that security annotations do not work because someone moved a method between two objects, and now you have local call, and security checks are not happening? Can you afford that? Isn't it fun? Yeah? OK. And then some people say, oh, it doesn't happen in my company. Doesn't happen to me. Never had this case. So there is this comic like, you are working on a bug, and I swapped 2 lines. No, just don't ask. And then every day I see, not every day, but from time to time I see people doing that. I swapped 2 lines, it started to work. So I shipped it to production. I added 5 annotations, it started to work. How cool. Right? This is actually what's happening. I start to ask question, what was the reason? There is no magic, there must be explanation. But people don't do that. They just happily accept that. So for them, Spring is working fine. They just wasted 2 weeks on swapping lines after something started to work, and yeah, this is fine. Everything is fine. They put, you know, there are funny annotations to help you solve the problems brought with other annotations. For instance, I do love this one, no repository bin. You actually mark something that this is not a repository bin. I want also no user service bin or other, but they were not accepted. And by the way, this is all explainable. You want to learn about it, there are plenty of books, you read all of them, and you have a little bit of understanding what can happen. This is a gentle introduction. Yeah? But what are people doing? They are not reading those books. They are just putting random annotations. This is exactly what I'm asking. I see a piece of code and I see, what is actually this annotation doing here? It makes no sense. Then I go to the developer. Why did you put this here? I don't know. I just copied it from other part of piece of code and it worked there correctly, so I assume it's fixing some problem. This is how you inherit. It's like a culture. Like, you know, I can, as a horologist, I see this is a culture of singleton being, this Spring singleton annotation that is going all around between projects in a company and finally reached other. Because people believe this is a magic. And by the way, magic, people think that magic is something that we don't understand. So I call Spring or Java EE magic because I don't understand it. Yes, I don't fully understand it, but it is not what is actual magic. Magic in code, the real definition that we use, that I am one of the people that support this definition, is a thing that does not compose safely, that is very fragile to changes. That's actually given by John DeGauss, one of the Scala gurus. It makes common case easy at the price that complex case are impossible or incredibly complex. Yeah? So magic is actually in Java happening whenever you use dynamic proxy, thread local, runtime reflection, bytecode manipulation, or stringly typed annotation. And then your production phase. Show you example. You know that there is this annotation, is one of the modules, retryable. It's very easy. If something happens, like exception, it will retry a method, like 3 times. Let's try again. It's very easy. You see that? OK. Then we have this infamous transactional. We'll make the method in transaction. OK. Very easy. Now we compose them. We have retryable transaction. Is transaction 3 times repeated? Or is 3 times repeated code inside transaction? Tell me. How can you prove that? It's actually, you can find it out. It took me, I think, 2 hours last time. But you know, then add security. And is security before? Or what if you cache something that should be actually checked by security? Is, for instance, someone get it, but it's cached and now security doesn't work? Actually, there are answers for that, but you have to read a lot of documentations and things that actually might change. So you depend on some code that's not even in your code base, but it's only documented. You cannot even put the breakpoint. OK. So this is a hidden cost of magic. Heisenberg's stop development. Really, I see people sometimes, when they cannot code for 2 weeks because data disappears from database, they sometimes call me. But I even heard, I've seen stories where it was like for months. Or, I love this. Who is using Mockito again? That's what you typically have. Because you have so many dependencies, you have to mock and mock and mock and mock. That's a mock starvation. And you test Mockito. OK, this is all hidden cost. OK. So Spring is not simple. It looks, but it's not. I have to slowly end. That I have like 5 minutes. Yeah, a little bit more. So my top 3 most dangerous tools. Actually, Spring is not the worst, what I think it is. JPA, actually. Really, people use JPA even outside Spring. But if you have this code, set name irrec, or get groups, will this change be saved to database? Actually, could be or could be not. Depends on the code that was before and after. You have to analyze a lot. Will this work? Depends on the code way before and way after. JPA breaks local reasoning in an incredible way. It's like total disaster. So this is the thing that I even say that people know better SQL than JPA and waste time transferring stuff from SQL to how to write it in JPA, how to map in with annotations in entities. And there are solutions for that, like use JOQ or stuff like that. OK, that will come. Application server. Who is still running on application server? That is, oh, don't do that. Like WebSphere, even Tomcat. You have class path problem. You have problems with new Java version. Debugging is horrible. Testing of that stuff is horrible. Like, who had heard about Archillian? The worst way of testing anything. But actually, you have to. You want a test that you can trust. So make jar not war. That's where I agree with Spring people, totally. And JSF, actually, really, it's not the worst web framework done, but it's very close to this. Yeah. So the point is, it's not that those guys doing that stuff were evil. They wanted us to suffer. No. I was there when those things were born. It wasn't exactly 2,000 years ago, but it was a long time ago. I remember Java EE first versions. And it wasn't there to solve you a problem of dependency injection. It was there to solve the problem of distributed computing. Distributed transactions, that's actually a killer feature of Java EE. Who actually now uses it? You don't. Or security in remote codes, or two-phase commit. Like, I would love to have two-phase commit. At that time, I believed this is exactly how we should do things, and that's how Java EE was doing that stuff. By the way, we could code big system. I was doing these big systems with Java EE first version, horrible with tons of XMLs, not having any dependency injection. And no one told me that I am really doing something wrong. Okay? And then we have servlets. Let's say, don't do this distributed transaction. We just do web stuff. We need servlets. And with servlets, the problem is they are created by container. If you want, let me test this servlet, but with different database, you can do that. Because servlet has a default constructor. You cannot put, if there is a default construction, you need the default constructor. You cannot pass anything. So servlet is breaking the dependency injection. You cannot have dependency injection with servlets. That's the thing. It's untestable. And actually, that's where Spring came. Spring was solving me this problem. How can I have servlet or something servlet-based, having been able to test it? Spring was really giving me a solution because it was hiding this part of joining stuff together so that I can test. There were also technical stuff, like if you do dependency injection manually, you need some kind of factories, providers, everything to make your life easier. If you have generics, it's easy. If you don't have generics, then you can only have very generic factor, which is horrible to use because you have to cast everything. So before Java 5, actually, dependency injection with XML was a really good solution. That's where Spring actually was started. And with lambdas, if I have lambdas, I don't have to do transactional. I can have this method, doing transaction, and here is my lambda. Here it started transaction. Here this lambda is called inside of transaction, and for instance, entity manager is passed here. And in this lambda, I write my transactional code. And then commit was automatically done, or rollback, whatever. This method, by the way, for instance, is written in JOQ. By the way, it's also written in Spring. You can use it like that. You don't have to use transactional. You can use actually transaction template. It's maybe more or less like this. How cool. This is a proper way of doing transactional, because it will never fail. It will work in a private method, in any thread. So at the time of Java 1.4, I would say that Spring was really the great idea and worked great for me, because I haven't seen better. And even up to Java 7, I would say there were not really many good alternatives. Spring was still, let's say, probably the best choice. But from Java 8 on, not only because of Java 8, but also because of different libraries and platforms and frameworks that we have, we can do the same stuff without magic. Like I am doing applications with Netty, with Ratpack, Spark, Java. By the way, there is also Spring Webflux. With Spring, this is a small subset of Spring, which actually I'm building applications which have absolutely no Spring context, not even a single bean, but the Webflux is starting them. This is really beautiful. Doing Spring without Spring. I like it. So there are why do you use Spring? I completely understand. Everybody does it. If I do something differently and I fail, that will be my fault, of course. And some people really like this magic because I put so many annotations. It's a miracle it started. How joyful this moment is. I want to repeat it. It's like extreme sport. I jumped, I made a skydiving and I survived. I want to do it again. More dangerous. I will put more annotations. Let's try this time. Okay? It's like a Stockholm syndrome. And developers basically, they don't see this, that I was just 3 days trying just to start a server. I couldn't do any work. But after these 3 days, it started to work. OK, Spring is great again. OK. Solutions. I have to finish very quickly. So one thing, if you still are having application servers, make jar, not war. This is step number 1. You have to do that. Spring Boot, by the way, is still good for this step. You can start with Spring Boot. I have no problem with that. But step 2, hold your beans. Not everything has to be a bean. You can still do Spring, and actually that is how many years I started with my teams. We still are inside Java EE or Spring, but we are not that eager to make everything injectable bean. We just make only the needed stuff beans, like controllers, RX stuff, whatever, but not everything in. Let's keep our business logic Spring-free. This is possible, this is beautiful. That's how I fall in love with manual dependency injection. Because I realized actually I save line of codes, not bring them all. Then the thing that's, let's say, optional, JPA is really giving you a lot of harm. Try alternatives. There are many, there are plenty. I didn't spend time to find them out. I'm using JOQ, sometimes query.dsl. I'm using other stuff from Kotlin, so there are plenty things. Step 4 is more, let's say, deserves a more things. Go functions. That's what I am doing now. Instead of doing stuff with annotations, I use the power of high-order functions. Like, I will just show you this piece of code. This is how, this is my aspect written in a functional way for Kotlin. Okay, and here was, okay, there was no, I haven't shown you how to use that, but there is a place, moment. Yeah, secure. This is my method. This is not, I mean, do that in secure context. It will never break. It will work in private method. It will work the same on tests and on production. This is cool. And you can have this code and you can debug it. So testing on functional stuff is way easier, even doing end-to-end tests. This is how my end-to-end tests look like. Start application with test database, check a result as a JSON, compare with expected result. And by the way, Spring Webflow starts in 200 milliseconds, or Ratpack that I'm using sometimes starts in 10 milliseconds. I can, on this machine, I can do 100 end-to-end tests per second, starting and stopping application testing the business functionality, end-to-end on a HTTP level, on a request response level. So step 50 is the most, let's say, controversial. That's also the thing I'm exploring, going monads. Transaction, believe me, is a monad. One day or later, because it's exactly wrapping something. That's how the monads work. But I won't talk about it. This is not this moment. I'm working on that. This is actually some code which uses monads to compose stuff, those how you call different method that has transactional annotations, and you make them running, in fact, in one transaction. This is exactly the thing you do with monads. But you don't have to go this step, because actually even step 2 is already really great for your code. Hold your beans. So ending that, of course, you need time to adapt. I understand that you will use still Spring sometimes because you don't want to risk new stuff. Completely understand, but you can reduce risks. I'm really doing, at the moment, Spring without Spring or just application totally without Spring, with Kotlin, Ktor, some other libraries. Just please, less beans, please. And do baby steps, and you will be fine. So, yeah. And by the way, Spring evolves. Not like some other platforms that we know. Maybe one day they will not promote beans anymore. They actually did already a lot to support functional programming. I still remember how they stopped promoting XMLs. So maybe there is a hope even for Spring. It will actually, I will be on this stage presenting you how Spring is great because it doesn't use beans anymore. Who knows? That's enough of my rant. If you want to know more, those are materials for you. Cool presentations. Dziękuję. Should you have any questions?